Hello, everyone. Good morning. I'm really excited to be here. Thank you so much, each one of you who has joined today for Redis Developer Community Meetup. So we are going to have an absolutely a great day today. By the way, there are plenty of exciting talks which we are going to do today. So just to give you an highlight around Redis Developer Community, it is basically a kind of a vibrant community of hundreds and thousands of community experts who are always there to try and share their expertise to the community members. So here we get a chance to hear from experts, learn from one another, and of course, we are going to see amazing demos also from the speakers. So today we have a special guest, Janis, and he brings 4.5 years of experience. He works in shipping technology. He's busy developing real-time data-driven products for the nautical industry, and he works in the company where the products like live dashboard and autonomous lane assist are built completely on Redis stream. So yeah, so let me go ahead and invite him. So here is Yanis. Hey Yanis, how are you doing?
Hello. Thank you so much for letting me have this opportunity to give a talk to all the people who are interested in sensors, IoT, and in general. I'm super happy to be here.
Yeah, thank you so much. I know it's too early for you, but thank you so much for your time. In waking up in the morning and reaching out to us. It was really good interacting with you during our initial planning. But just to let our audience know that he's here to talk about how his company has been utilizing RedisStream to build their own real-time data-driven system. So let me go ahead and add your slides, Yanis, and over to you, Yanis. The stage is yours.
Yeah, with no further ado, let's begin our talk about what we do at shipping. So firstly, I want to say thank you to Ajeet for letting me to join here and give a presentation. I actually managed to do that because I recently joined the Redis Labs Discord community. So I recommend you doing the same. If you have any questions regarding it or want to start, you definitely should join there. I or any other people who are very interested and intrigued about your problems, they can help you out with that. So that's kind of how I started with all this. So I wanted to give a little shout out to that. But yeah, with no further ado, let's begin our journey. So about me, I'm a data engineer at shipping technology. I think already for 3 years. We started. We started as a really small company, still pretty small. We had like 5 developers. I'm one of them. And my background is in IT. I'm a master's in information technology, and of course I love tech and especially IoT and all the real-time sensors and everything. So shipping technology is definitely the place for me to be. And of course, I also love playing games, but it's kind of relevant. And I think one more fun fact: 2019, my 2019 resolution was to travel a bit more, but hey, here we are. So it's a bit of a bummer. So my goals for this session is to actually showcase how we use sensor data and how we collect them and process them at shipping technology. And by doing that, maybe most likely I will convince you to use Redis streams where it's applicable. And of course, if you see these little dinosaurs on the left side, you can use your phone while you're watching, or you can use your phone to scan things and open up and learn more about what I am actually describing on the screen at that particular moment. So we have this nice picture on the right side, and maybe let's start with that one. And this is kind of how shipping industry or inland shipping industry in the Netherlands and Germany looks like. This is one of many corners of one river that stretches far in Europe, and it carries a lot of cargo from Port Rotterdam up the river and back down and through other ports. And it's a complex riverway of different challenges in between. And so this is the industry, or this is the place where we kind of find our clients, and this is the place where we kind of go into. And as you can see in the picture already, you have multiple types of ships. They're pretty long, and the scale is pretty crazy. So yeah, that's something that before I joined shipping technology, I had actually no idea about that. Yeah, there's like this huge market about that. That has not yet tapped into the data drivenness yet. So this is one example of one of the inland ships. This is a hodl ship. It stretches like around 100 meters long, and it's around 20 meters wide. And this is just one case of many different types of ships that we kind of equip with. And as you can see in the background, this is the seagoing vessel. Back in 90s, it was considered one of the largest vessels. Not one of the largest, but like a really good sized vessel. And if you compare it to the inland vessels right now, different shape, but in terms of like complexity and length, it really poses a lot of challenges for us at shipping. Just to explain a little more, the river is quite busy with all these little vessels, and if you want to learn more about and explore a little bit more about like these AIS data, you can definitely check it out on Marine Traffic. But basically, this is the kind of setup for us. It's very busy. It's a lot of data coming in, a lot of sensors, a lot of people, a lot of captains making mistakes, a lot of accidents happen. So there's a lot of things that we can learn and a lot of things that we can improve in shipping industry. And we might have focused too much on sea-going vessels and ocean-going vessels, and we kind of have left aside the also quite important part, the inland shipping. This is another type of vessel that we use. It's actually one of our test ships. And it stretches like 110 meters long. It has loads of sensors. Just for a little reference, I can showcase a couple of those, and you'll see what I'm talking about. We have radar main in front. We have GPS front. We have echo sounder sensors. We have immersion sensors. 3 on each side. We have on the back side, we have another GPS, another radar, just to be sure that you have extra if you're traveling. And we have engines. Of course, there are a lot of sensors in engines. What are the RPMs and stuff like that? And of course, we have weather station. We have loads of other sensors from the outside. Let's delve into the cockpit now. This is a typical view from the captain's seat. This is how you would be operating a ship. Again, you have loads of sensors here. You have pilot modules. You have radio to communicate to other captains or to communicate to port. You have engines. You have manual controls. You have cameras. Again, the radars, and more and more and more. You have loads of sensors. And our goal for shipping is to use these sensors and to learn a good way to or make the ship more kind of aware of what's going on. And we want to also explore the possibilities. How can we improve inland shipping industry in general? And our main actually goal is to make inland ships semi-autonomous or autonomous. Semi-autonomous, fully autonomous mode is quite difficult to achieve, and captains do pose a lot of great input, and they're necessary for the inland ship to really operate well. And there's a reason why you have captains on board, and there's a reason why you have captains on planes. They are they're full of information, and we still would like to have that. But as shipping, what we would like to do is learn as much from those captains and their behavior, and see how can we improve this. In terms of autonomous or semi-autonomous mode, we have a thesis: if a captain can operate in a ship in a great mist without looking outside a window, just by looking at the sensors, I think computers can do that too then, right? So that's kind of our methodology in approaching this semi-autonomous way. The other thing is that we collect data and actually showcase them on online dashboard, which I will showcase later. But we also have other products than the autonomous lane assist or autonomous stuff. We also build reports for captains and ship owners or companies, and we also have predictive maintenance, problem solving. So basically we have quite a lot of things that we can kind of solve. This is yet another cockpit from the captain, a bit fresher, but like my point was to showcase that there are many different sensors, and not, of course, none of the ships are the same almost. You have little sensors here and there that are a little different from ship to ship. You might have 2 GPS sensors in one ship. You might have 1 GPS sensor in other ships. So the whole kind of fleet of ships that are deployed on river, there's no ship that is the same to another. So it's quite a challenging thing to kind of build upon, since you don't have any one standard model. If you would compare to Tesla or something, they are building a couple of their own models, and they really can utilize the opportunity to build their own way. While in shipping, we try to connect as many existing ships as we can, and not to influence the already existing ships with new sensors, new and expensive sensors as they are. So yeah, and behind all this, there's a lot of wiring going on, like it's crazy. And we tap into those wires, and we use these wires. There are a lot, and there's more. So we have a lot of electricians and helping hands to actually connect these sensors to our black box. And what we do is we take all these sensor data, and we feed it into our server edge computer. It's just a computer that takes in a lot of Ethernet ports. It takes in audio jack, and it basically funnels all the data into a black box. And this is what we actually call it. We call it a black box pro. Since reason why we call it a pro, because, well, it does collect data, it does store the data, but we also send it to clouds. We also operate over it. We, of course, as I said, we have autonomous lane assist and other fancy gadgets to help us to make it more pro than a regular black box. And of course, it does really help industry, the fact that your black box actually is sending data to cloud almost in an instant. So your data is almost always recoverable, except for cases where you might not have a coverage or something, but then you can go on board and recover the black box as it was normally meant to be. One thing I wanted to mention as well, we use this little server, but underneath inside that server, we use Docker. So we use microservice architecture, which is perfect for Redis. And of course, we use Docker Compose to kind of orchestrate all these little microservices. And for like scale of 1, or like we have, our scalability is per ship, so we don't have to worry much about complex multi-cluster systems for each deployment on ship. While in cloud, it's a little bit different. But I'm not going to focus on the cloud, but wanted to mention one thing, that on cloud we use Kubernetes, so we still use containers on cloud. We also use for our Google Cloud, for our cloud provider, we use Google Cloud Platform. There's no particular reason why we chose this. It's just because me and my colleagues are most familiar with it, and we went with that. But what I'm showing you guys today is it's applicable also to AWS or any other cloud service provider, since we mostly use open source, and since all cloud providers actually underneath run the similar open source software. Yeah, so I showcased quite a lot of sensors. I showcased a lot of interesting things, but so I also kind of dabbed into the products, but I didn't really stick to it. I wanted to mention what we can actually do with all this, and of course, we can make an online dashboard where you can check live or replay actions, what your ship was doing. We also have collision detection. We can make a collision detection, or to see if you're going to collide with another ship, or to see if you're going to collide with land, or a pillar or something. We have, of course, the semi-autonomous sailing, and we monitor the health of the ship or health of the sensors and see if things are going well. Also, we starting to work on emission data and see how ships are performing compared to what we would like to expect. So some ships are retrofitting their new or old engines with a bit more efficient ones, and then would like to know whether or not they're doing better. So yeah, that's the way to do it. We collect data and see on historical data if it actually is doing better. So that's a really great opportunity. So with all this, we actually with our microservice architecture and everything, we actually use Redis as our primary database, and we also have MariaDB on each of this in each of deployment or each of edge server. But actually, Redis is the main primary database, and there's to be honest, there's a good reason for it. It's a simple setup. There's really low maintenance. The most important thing is really high throughput, and since we have a lot of microservices that collect data and process them and clean them and do other stuff and prepare for other processes to do that, so high throughput is quite important for us, since you want to be as fast as possible but reasonable enough. Ships are not moving as fast as F1 cars or anything, but we still want to have quite fast access to fresh data. And initially, we thought Redis has pub/sub messaging, which is amazing. And since 3 years ago, I started. Actually, since we started building this whole infrastructure, we found out that Redis streams came out with a version 5.0 as soon as we kind of picked this project up. And we started reading this, and we really thought this is really good way to build a black box, and a really good way to build the system for us. And I will explain you why. But first, a lot of people ask why are we not using Kafka or anything? There's a simple answer, as I said, the simple setup for Redis and simple setup on high throughput for Redis for one scale, because we don't have complex clusters for Redis. It's just there's no reason to there's no reason for you to consider basically any other thing. Redis is just way more performant, and you have a lot less hassle to develop these things. If you decide to do something on cloud and aggregate things together, you can do what you will. But personally, we still use Redis on cloud as well, since we have a similar setup on cloud. We want to have consistency both on ship on cloud, and Redis on cloud is as performant as it is on our ships. I think this is the time I give a little brief, my personal explanation of Redis. Of course, you can check in Redis Labs. They have Redis Labs, or the developer Redis website. You can check out an actual detailed explanation of Redis, but I'll give you a brief summary of this. So how I see it, Redis in our system is a little post office service, which basically takes in all the data, and we use it as a sorting system where we place our data in many different streams, and we use it to deliver our data to important services that require them. So yeah, that's kind of the abbreviation of it. But let's talk about Redis streams, because that's why we're here. I see Redis streams as like a Redis streams basically is a logging data structure, and logging data structure is a super powerful concept in just in general, in terms of black box, in terms of data collection, and in terms of event processing, and in just terms of real-time data, because you have this concept of chronological data, and you just append data to a stream, or to basically a queue. And you have three different concepts. You have historical data, you have the newest, freshest message that just came in, and you also have the next message, basically the message that has not yet that you have not yet received, but you can possibly wait for it. And in Redis streams, you have this concept of a producer, or you have a command X add. In Redis, every stream command is prepended with a letter X that indicates that it's a stream. And X command is just adding the next message to a stream. That's simple as that. You just add the next message to a stream, and it has, if you don't specify the ID, it will generate for you the timestamp of that message. It will generate the timestamp for that message, and it will also prepend the ID, the unique identifier, just in case you have so many messages coming in at the same time that you cannot uniquely identify this message based on the timestamp. But in our experience in shipping, we rarely see this unique identifier going above 0. So Redis precision in timestamp is actually quite high. Of course, where you have a producer, I guess it makes sense to have a consumer. Consumer can be a Python script. Consumer can be just a command line command, and also the consumer is just a command that you type, or this is a command X read. Of course, again, prepended X. And again, as I said, you have kind of 3 modes of operation. You can read historical data, you can read from any timestamp you want, or you can read basically real-time data, the freshest message which you just have, or you can just block and wait for the future message, which is very powerful if you want to have a highly responsive service, and if you want to respond to data as quick as possible, and you don't need to process all messages, for example. There's another concept called consumer groups, which is again going to be very powerful, going to be quite important for our next slides. And this is the bread and butter for our for shipping technology and how we process many streams. Actually, group basically is a group of scripts or group of services that work together on the same stream, and they work together to process messages without reading the same message and without colliding with each other with message reading. So Redis will deliver for each service its own message to process. It will tag that particular consumer is trying to read the message, and there are also mechanisms to claim the messages away from the consumer if they're misbehaving, or there's there's something like a bad something bad is going on. So you can always also claim the messages back to the other consumers. So it's a very powerful tool. I'll explain a bit more how it's being done, but this is something I'm super happy about how it's being implemented. Of course, there are more queries. My favorite one, this is by far my favorite one, and it's xref range. Basically, you can query messages in a range of timestamps, and it will return return messages ordered by latest message. And once you start working, you'll see how powerful it can be. And you can use that for basically extrapolating things. You can check on progress of your data and stuff like that. The X-ray range is quite powerful. And yeah, as I promised, I wanted to showcase a little bit of the Redis in our context and how we use it in our data pipeline. So I'm going to introduce a little bit about our data pipeline, and then I'm going to give you a little example of how we use Redis in a couple of cases. I will not show you loads of cases because we don't have a lot of time, but I will show you the most frequently asked case, and then I will show you the kind of concepts of how we build our future kind of streams and services. So imagine a situation where you have all these sensors coming in, and you have certain scripts or certain code that is processing all these messages, and they capture all these. You have serial data, you have radar data, as we mentioned, we have engine, audio, video, more. And you have these services that are processing them, and they just picked up the message, they parsed it. Maybe it's a weird message coming in that is in full binary, and we don't want to have fully binary message. We just want to parse it as an actual viewable image, or we want to actually listen to audio. So we need to kind of process things as they come in, and it's quite important for other services to have kind of common ground and normalized data for us. So we have these capture services, and yeah, we use the data parsers and other tools to kind of gain understanding of these captured data, or we can call them raw data. And we have kind of sort of data distributor. Basically, what it does, it understands, or basically it tries to sort all the messages in Redis. So we end up having these multiple streams of Redis, or multiple Redis streams, basically. For example, we have GPS RMC. RMC is again some standard which encodes latitude and longitude. And yeah, this is how we kind of depict all the different streams. And each stream represents certain kind of concept or certain sensor or certain kind of area of focus. And we kind of pinpoint or we narrow down with the responsibility for each stream. So for example, if I would like to get the GPS our GPS front position, I can always access it by reading the Redis stream GPS RMC front. If I would have other sensors, GPS RMC back or something, I could use that to access back. And that's where the power lies. We can just make as many streams as we want. Literally, we can make a lot of streams if you want to. But it supports like literally over, you can make 300,000 streams and Redis will not chug it up. Of course, we have like less than 100, but still. So yeah, this is the most frequently requested concept, because, well, that's where you always start. In data engineering, I guess, or in product building, you always start with collecting data and trying to understand what's going on and see how you can, for example, build a machine learning model, but you need data for it. So we have to collect it. And in order to collect, I guess you need to use some sort of database somewhere where it's more reliable than being on board on ship, since, well, you'll have to use data for your data science models. We cannot just go on board and tap into a computer and just learn the models from there. So we have to send it to cloud, and we have this service called Push to Cloud. And basically, what it does, again, I wanted to mention we use Google Cloud Platform, but it does not matter really, to be honest, how it's being done, executed, because conceptually, I think all stream providers and even your custom server can do what we're doing right now. So we have these Redis streams that I mentioned already prepared. We have the concept, all these data streams coming in, and we want to have them in our custom API gateway to be processed, and we use Google Kubernetes engine, and we need to somehow get all the messages from each individual stream to Google Kubernetes API gateway. Yeah, we can focus on one message now, but conceptually we can just replicate the same thing for all streams, and even Redis can build a query to just query all streams at the same time. So you don't have to worry about that. And we started off by having push to cloud as a concept where we want to always have live data, because it's always nice to see on the dashboard your live location. It's always important for a reason, because you want to, or as a captain or as a ship owner, you would like to know where the ship is located. It is located at the moment. And we also want to send, since we're a black box, we also want to send our data to cloud and learn and everything. So we also want to have some sort of service. If you fall back, then you can, if you fall back in connectivity, then you can try to push it as much as you can while you have time. So that's kind of the concept of how we understand how we want to have this, but for many different cases, you might have different solutions. For example, some people just want to feed live data, or some people want to feed all data without needing to be live. There are different modes of operation. Redis streams will support all of your modes of operation. So yeah, let's dive into a little bit of Python code, and I promise it's not going to be difficult, and I'm going to explain you real quick as we go. So we just make Redis client. Nothing much to say here. We just call it R for now because of the slide limitations. I cannot name them properly and long. So yeah, let's imagine we have a connection to Redis under this variable R. And if we would like to read, or if we would like to push data to cloud in a live mode, we can use this command again, read group, as we saw it before, and we can specify our streams. In this case, we have GPS RMC front, and this particular mode sets to, I want to have messages that have not been delivered to any consumer. This is one of the settings that you can set. It's very powerful because, yeah, of course, if you want to send data only once, then I guess you would like to process it only like that. And if we have a question, do you have the overall architecture in terms of access with the cloud, and what components are hosted where? Yeah, so overall architecture is I will explain you a little later, since we're going to do quick questions and answers a bit later, but this is a really good question. I'll get back to that. And yeah, so we have this, we can specify a group name. So we can make Redis consumer groups, and in this case we have upload group, and we can specify consumers. So we have a consumer live, and we can have a consumer historical, or consumer pending, or whatnot. And this is also one key feature, a block. Basically, you can say, give me all messages that are not read, and that will come in the future. So basically, it's literally live. Like, as you get the message, you will process it and store it in an X variable. So that's very powerful if you want to operate with on live mode. Then you basically got these messages, you process them, whatnot. Basically process means, in this case, you push it to cloud, post it, maybe do some other operation, log it, whatnot. Depends on what you need to do, and then you acknowledge them that you have sent them. If by any chance in your process you have failed or something happens, they're not acknowledged. That's where the pending service kicks in. And you have another command. You can check for expanding messages. Redis also has like this convenience function, pending range, where you can specify in which range you want to look at. Here we can see we just look at the whole range. So minus is beginning of the stream, or the inception of the stream, and max is the end of the stream. And we want to claim or check how many messages is the live consumer actually hogging up. And we will receive the IDs of all the messages that live service has failed to send. And we can just claim them to our pending service or pending service or pending consumer. And yeah, you just claim them to yourself. And you can also specify idle times and stuff like that. So it's very powerful to kind of operate in two modes. And since perhaps live has missed, ship had a bad connection or something, it might have missed a couple of messages in a live mode. Pending service will pick it up, and after it got a better connection. So that's very, very powerful. And of course, you claim those messages and you basically do the same operation as you did for live. You read them because you have claimed them, and yeah, you just process them and post them again. And it's simple as that. And of course, like the custom API gateway you have, or you can also have integration with already some cloud resources or cloud services. It doesn't matter. We use our custom gateway to also, for security reasons, we try to validate that the ship sent the data rather than someone else, and we want to make sure that there are no bad actors in between. And we also have freedom of using the gateway to fan the data into multiple services and see do test or do whatnot. So that's why we use a custom API gateway. And yeah, this is together makes the whole thing work, like how you push the data to cloud using only Redis streams. And most powerful part about this is that in this whole concept thing, I have never had any state management of my own. I actually used only Redis. And that's the most powerful part, in my opinion, about these Redis streams, is that it manages your state of your consumers, it manages everything, and you don't have to worry about anything of that. Well, you still have to worry about it, but in a different way. And you also have multiple modes of data processing. As you saw, we had push all data and push all. I don't care if it's old or new, just give me all messages, I'll push it. You can also have FIFO, LIFO, and whatever reading mode you can have. One kind of drawback is that you cannot request or you cannot query for messages with a particular field in or whatnot. You basically query them based on time. So that's a drawback, but perhaps you could check Redis Labs for their modules, what they have implemented. And there are a couple of modules that are very powerful in querying your data structures. So that if you ever need that particular use case, you should check out Redis Labs for that. There's another case of multiple streams. I'm going to touch it very briefly because we're kind of running short on time. But concept of multiple streams is that, you had this, you read the stream. Okay, I'll just showcase it in a better way. You have multiple streams and you have certain service that kind of consumes multiple streams. And again, you can have different modes of operation where, for example, I want to extrapolate the position of a ship, or I want to predict where I'm going to be at in 1 minute. I can use stream. I can read the latest value from GPS RMC. I can read the latest value from our radars. I can read the latest value from our engine, if it's on or not. I can also say I can try to read GPS RMC with Xrev range. I want to read past 20 values or last 20 values that were committed or that were sent to the stream, and I want to see how they I want to fit the line and see where the line brings me in 2 minutes. So that's kind of the powerful thing, that you can have multiple inputs and they're very fast, and that's how we utilize this multiple kind of stream setup. And in the end, we publish it back to Redis as another concept, and we just store them there, and we have a new abstraction layer on top of raw data. We have future positions, but you can imagine you can have multiple ways of building these concepts. And to be honest, we actually have a bit more complex case here. That's how we kind of, this is the view of how our Redis streams are kind of interacting with each other. Of course, you cannot see much, and there's a reason. It's not like I don't want to share, but the streams are irrelevant, the names, but the fact that you kind of pipe them and make your own data pipeline to come to the kind of particular stream in the future, it's very powerful. So that's how we kind of use these little direct acyclic graphs to feed from each other and build our own understanding of what's going on board. This is something we're super proud of, and this is why we actually use Redis and Redis streams. We build these little data funnels, and slowly we gain the understanding of what's going on board. And in the end, we have prepared a message on particular Redis stream, and we can just read it. And service does not have to hold any state. And once your service fails, or you have a web service or whatnot, it just will pick it up and take the last value or last whatnot values, and it will chug it up and continue going. So that's super powerful from this kind of conceptually, that you can build these data pipelines literally to make higher and higher abstraction of what's going on board. Because at one point, you don't want to rely only on raw data only. You want to start building some knowledge base. So I will briefly showcase how it looks like on board, on the clouds. Since we pushed all data to cloud, I need to prove it, I guess. And this is one of our ships. It's a test ship, which you saw, the 100-meter long ship. And this is our dashboard. This is a kind of showcase to say, hey, we have your data and it's here, and you can replay them and check it out. And this is a case of Factor 4, that's our test ship, sailing on 31st of July, and we can see exactly what was going on board. And you can see the heading of the ship, the depth and whatnot, and we can actually replay it. We can replay the moments and see how it was sailing over time. What were the engines? What were all sensor readings? But not only that, we use those sensor understanding on. We use this to understand how sensors are doing, and we understand how ship is behaving and stuff like that. Of course, we can replay it as well. It plays. You can increase the speed. It's like a real data player, and of course, this is the software that is on board. We replay it also on cloud. Since you have the same kind of namespace or same infrastructure, you can just duplicate what you have on the ship. You can duplicate it on cloud and just replay it there. So it's very powerful. You can reuse the same stream names and stuff like that, prepend it maybe with unique identifier of the particular ship. But basically, that's how it is. We use WebSockets to communicate. We use WebSockets to communicate front end to back end with Redis. And of course, we can go live. I don't think the ship is under maintenance right now. I don't think it will go be active. So unfortunately, the ship is down for maintenance, especially for us today. Especially for us for the presentation. But this is how we send data to cloud and prepare data and showcase it. And of course, you can imagine how useful it is for all the insurers to work on. Oh yeah, my computer was just slow. But as you can see, there's no data now. We don't ship is offline, so we cannot showcase any data, and we cannot visualize it by we're blacked out. But once the ship goes off online, we will have this pending service kicking up, and it's going to push all messages to cloud as a one consumer. And of course, we'll have also live data. While it's pushing the historical data, live data player will send a message once in a while to kind of update the state. Here I am. So yeah, that is how we basically have a perfect view of how our ships are doing. And you can also see that since we can showcase it on the dashboard, we also have data in our database. Therefore, we can learn and learn or make our own models to build our next product. So yeah, that's that's how we kind of make this whole pipeline going. And yeah, this is the end of the presentation. I'm sorry, like this is a weird ass slide. But yeah, this is thank you so much for your attention. I wanted to answer the question which went in. Maybe we can do that with
over
help
the
of
screen.
Ajeet.
Yeah, it's over the screen. Yep.
Yeah, we have a overall architecture in terms of black box communication. So I didn't put the image because it could be a bit daunting, but in simple case, there is one-way communication always from black box to cloud. And basically, you have a public-private key kind of setup where you basically communicate with the gateway, and only you under that namespace can communicate with the gateway. And we don't await any data. We don't expect anyone to be sending data to a black box, and therefore we kind of close all the inputs. Black box will always request things if it needs. And of course, for maintenance we have some SSH access, and for deployment we also use a secure access, and we have our own open VPN server. That's also quite important. So yeah, that's kind of two ways, right? So you have like a black box communicating, it's communicating its own, it requests its own data, and then you have like maintenance side where we use SSH and we can do maintenance underneath, and we can orchestrate stuff from that secure way. And the second question was, what kind of help does the captain get? Yeah, captains, for a couple of ships we have more products than others. For example, some ships might not have good enough sensors to have autonomous sailing, just because, well, their sensors are not good enough. We want to have some reliability on the sensors, and unfortunately, a couple of captains cannot. Well, firstly, specifically captains will be able to have a better kind of view on what's going to happen in next 2 minutes or next 5 minutes. That's a great kind of view on world, so they have ease of mind. They will be alarmed on any weird behavior that other ships are doing. Since we use some AIS data and we use radar data to kind of understand where the other ships are, we can actually see kind of behind walls in a way, and we can see a bit further than a captain. Even though the captain uses the same sensors, we can just tap into actual data stream and query a bit more than that, and we can process a bit more complex inputs than a captain. But of course, we cannot do everything that the captain does. There's like important decisions that captain has to make, and we try to make our best effort to inform the captain what is the best decision to make, or rather than we try to inform the captain for him to make the best decision. So we don't want to tap into it too much. And yeah, that's basically how it is. And in other cases, there are ship owners, not only captains, and ship owners also would like to know if captains are doing great. So it's like sometimes it's a difficult situation where captain is distracted by something, and it might be that might lead to a bad steering decision. And you see the rivers are narrow, and it's quite often you can get kind of short and we would like to inform the captain, hey, be careful, this is a tough corner or something. Yeah, the specs of the black box. So since we use Python, we're not worried about the performance, of course. Well, Python is actually, we're more worried about development speed, so we use Python. But the black box, I can say we're using a mid-tier CPU that is from 3 years ago, something like that. Maybe that will help you, but I will not say exactly the specs. But and then also we have for Redis, you think we have to have a lot of memory. We actually, for Redis, we don't use more than 5 gigabytes of memory, and in total memory for us is 16 gigabytes. So basically, imagine you have your laptop. That would be our black box in a way. And some people have better laptops, but imagine that your laptop can run all these services, since we know it since we're developing on our laptop. And the black boxes are just a bit, well, not a bit more, they're more powerful, but you don't have to have a very fancy device. We have a lot of overhead in our resources. And I think that was the last question. Are there any more questions? And thank you so much for your questions, actually. That was very informative. I hope it helped you and answered.
Yeah, Janis, thanks a lot for your time. I think there were great questions and you answered it quite well. So definitely there is an interest from the audience to know more about it. So maybe once, so if you really want to interact with Janis, I think the Discord channel is the best way where you can ping him, and maybe you can connect to me and I shall connect to Janis itself, or you can directly reach out to him.
Yeah,
but
definitely
Janis,
Discord is the best. Definitely Discord is the best place if you want to get started. Also courses, people will help with courses and stuff like that. It's it's just amazing. To be honest, I recently found out that actually Redis Labs is doing a lot of good stuff for community. I was super amazed. And also this one last footnote or end note is that this might seem very unapproachable, like these sensors and everything. So it kind of, to be honest, for shipping industry kind of is. You need an electrician to kind of get into these sensors. But to be honest, IoT sensors are I might have scared a lot of guys. So maybe let's start with not equipping ships, but let's start with something a bit more achievable and still amazing. So I guess I will sign off, and Ajeet.
Yeah, sure. Thanks, Janis, for being here, and thank you for your time.
Thank you so much for your time, and thank you so much for the audience to bear with me.
Yeah, thank you. Yep. Okay, so we have a next session coming up, and I will be going ahead and presenting about IoT sensor analytics. So let me go ahead and share my screen. Okay, so give me some time here. Okay, let me add. Okay, I'm already there on the stream. Okay, and let me go ahead and present it. Okay, so the topic which I'm going to talk about is IoT sensor analytics using Docker, RedisTimeSeries, and Grafana. So let us get started. A little about myself. I am a Docker captain as well as an ARM innovator. I have been writing a blog from past like 5 to 6 years, and it is on collabnix.com. This is my personal blogging site where I write a lot about Docker, Kubernetes, Redis. There are around 250 plus blogs which I have written around Docker and Kubernetes. So definitely you can go ahead and check it out. I'm also a Docker community leader. I have been leading a Docker community as well as the Redis community together. Right now, I'm working as a developer relation manager at Redis Labs, and I worked in the past, like I have worked in the companies like Dell for around 8 years, and VMware and CGI. So the thing which I'm going to talk about is, let me start with something, to give you the context, like why I'm talking about the Redis time series itself. And this is one of a kind of a robotic platform which I'm working on. which is called as the Cherrybot system. Now, Cherrybot is one of the project which I started along with one of the Python developer around like 5 to 6 months back, and it is all about AI-powered payload delivery system. It has around 4 wheels. The idea is this is the first diagram or the first thing which hit my mind when I went ahead and drew it. And the idea is building an autonomous robotic platform which is equipped with Jetson Nano as well as GPS modules, cameras, lidar sensors. And this robotic platform is going to be a kind of a Swiggy guy for you. So think of it as like how you order a food from Swiggy or Zomato today. You just order on the mobile app and the food is being delivered to you. The same thing is what this Cherrybot is going to do. The main component which I have been using for Cherrybot is a Jetson Nano, which is like an AI computer from NVIDIA. And I have been talking a lot about in a lot of meetups and conferences. But this is one device where you have a complete GPU inbuilt into it, and where you can run all those AI workloads. It comes with the GPS and swappable batteries. Right now, the swappable batteries last for around 30 to 1 hour, but that can be extensible. The beauty of this device, the prototype, is more like it uses a deep learning platform to interpret all the data which it gathered from the environment. Okay, and there is a reason why we do that, because it has to detect all the objects. It has to be a fully autonomous system, right? And it can also identify the objects and people, and it can, in order to avoid the collision. If you really want to know more about it, this is my GitHub repo where you can find all this information. I am planning to update it, very soon, because I have written few of the blogs and published in collabnix.com, which is my personal blogging site. Now, the Cherrybot system, right now, if you see, the usage is going to be across the 3 different industry. One is the food industry, one is in the conferences for distributing the swags, and one is in a kind of a medical industry, like medicines, where it will be able to, think of it as like in a food delivery. Say you have a university, and within a university premises, you want to deliver food. And because that is a limited area where you can take care of it through the GPS or the camera module. So Cherrybot is going to deliver the food provided with all the authentication and authorization, where it will authorize through your mobile phone and you can collect food. In the same way, in the conferences, when you have you want to distribute a swag, so Cherrybot is going to help you in the distributing the swag. So right now, you basically visit the booth and then collect the swags, right? So Cherrybot is going to come near to you, identify you, and based on your interest or a facial expression, it is going to deliver you the swags. In the same way, we have a medicine delivery where, say, if the nurses or doctors want to go ahead and deliver the medicines in a touchless basis. So this is the robotic platform which is going to be in use. Now, as I said, right, we started working around 5 to 6 months back, and the base or the foundation object which we the robotic platform which we choose is RoboMaster. So RoboMaster is a product from DJI because we need to have a kind of a mechanism wheels. So that is the reason, and we want to start with something like how the robotic platform is going to respond to your image recognition, or you saw the clap recognition and all those things, right? The line recognition. So it all started with a kind of a bunch of hardware. It took us some time because of the COVID reason. We can't travel abroad, but we managed to get all of these things in place, trying to teach Robert all those sort of, the vision marker recognition, clapping recognition, the line recognition, color recognition, and all this thing. And this is our setup where we started working together. We started building around it. So if you see, these are the like mechanism wheels of the robotic platform. So think of it as like if your robotic platform goes ahead and is stuck somewhere. So these mechanism wheels helps you to basically tackle the obstacle and then take a different direction itself. So that it is very easy to go ahead and control. You see all those electrical equipments here, the wheels and all this thing. It took around like, I would say, 1 or 2 days to go ahead and assemble completely. You see on just below here, you see a kind of a battery. So this battery lasts around like 30 minutes to 1 hour, but provided we are in the prototype phase, right? So we just wanted to get started with it. Now, this is how the baseline of RoboMaster is going to look like. So if you see here, one of the component is a Jetson Nano, and this is an AI computer. This is an IoT edge device. And this Jetson Nano, what we did, we basically placed on top of it. And then we have an arm here, which basically goes ahead and try to fetch the things, how to, even if say, if we are adding some kind of a food packets onto it, the containers, basically, I'm talking about the robotic container where you have a kind of have a space inside where you can place all those food materials. So these devices, like all of these things, will be controlled by a Jetson Nano device. And this is on the right hand side, which you see here. We need around 5 volt 4 ampere power supply, and then it comes with the GPU, and you have a Wi-Fi module on top of it, which basically through the phone you can connect to the RoboMaster, and then get the packets. Now, there were a few of the challenges which we faced. One of the biggest challenge which we had is, like, when you have a food packet inside this container, there is some kind of a temperature which has to be maintained for the food so that it remains fresh. And that requires your pressure, humidity, and temperature inside the container, and that has to be maintained. And that was one of the challenge. This is the basic 3D printer model which we started looking into it and try to build very similar to it. Still, we are in a phase where we need to add a lot of things like a flap. We need to go ahead and add a lidar sensors. GPS model is in place, but one of the challenge which we were facing is finding an intelligent IoT based food monitoring sensors which can help us detect what would be the quality of the food inside it. And that is where we came across BME 680 sensors. Now, these are the sensors which basically sits right on top of your IoT device. It's a low power gas, pressure, temperature, humidity sensors, and it is being used by typically in multiple industry, right? Even if you are in indoor, you want to check the indoor air quality, you can check it. Home automation, it has been used. Internet of Things, weather forecasting. And one of the the pain point was to have those kind of a sensors equipped into your IoT device, you need to have a breadboard or something. But these sensors directly you can attach it on top of the Jetson Nano. One of the problem which I faced during the early phase is like BME 680 was not available in India last year when we started looking into it, but right now we managed to get one, and also we have one in the remote. So we have around 5 node cluster on the remote where we go ahead and test. But this is one of the sensors which directly you can insert into the Jetson, and then you can start playing around with getting all those metrics. So once you connect this, actually there is a Linux command called as IC2 detect, which basically try to scan your I2C bus, and then it basically detects whether the sensors has been loaded or not. Because the Jetson Nano runs an Ubuntu OS. It comes with a Docker pre-installed, so you don't really have to go ahead and install Docker on top of it. It also runs Kubernetes. So it is a kind of a credit card size device which allows you to run the AI-based container workload, right? All those things. Now, the thing which I am going to more interested was, like, how can I get those, because I need to measure the temperature inside the container, whether my food stuffs are fresh or not. And that is why I started looking at some kind of an architecture where, say, if I really want to build an analytics tool around it, and that is where I came up with a kind of an architecture, and I usually blogged around it early this year, where you have a sensor data where you are going to push it to the RedisTimeSeries. Your RedisTimeSeries can be running on your laptop or on your any other machine or directly on the Jetson Nano. So today you can compile a container image of RedisTimeSeries directly on the Jetson. And then the next step was, okay, we have a data. Now how I can go ahead and plot it over the Grafana. So today in this session, I'm going to show you a kind of a step-by-step, like how I all started, how I used Redis Enterprise Cloud. You can also use, the Redis database itself. You can build a complete stack on top of Jets and Nano also. But I want to show you like how Redis database, which is running over the Redis Enterprise Cloud, which is like a free of cost, I would say till 30 MB space, you can use that. So I'm going to leverage that as our Redis server. And I'm going to run a kind of a Docker container, which basically has everything compiled in Redis plus RedisTimeSeries on top of your Jetson Nano board, and then I'm going to push it to the Grafana for a fancy dashboard. So before that, I have one slide which talks about Redis time series. Now, you know, the Redis is a kind of a popular NoSQL database. It is key value paired database, key value based. But one of the thing is we have a support for all sort of you might have heard about data structure and all this thing. But one of the thing is Redis too, if you really are using a kind of say document based database. Now we have a Redis JSON which can fulfill your needs. In the same way, we have a Redis AI. There are certain modules, around 6 to 7 modules, which you can, if you go to developer.redislabs.com, you can see like there are a list of the modules. We have Redis JSON, which handles your JSON document. We have Redis AI, which has a tensor inbuilt into the Redis database itself. Your data is very closer to it. We have Redis Search, which works very similar to how the Elastic Search works right today. So the idea is you don't really have to rely on third-party tool. Everything is available in the Redis itself. And Redis time series is basically a kind of database which manages your time series data. So whatever the data which you get from sensors, those are like a timestamp data, like during the course of time, what are the readings from temperature from the sensors, irrespective to temperature, pressure, and humidity. So those are in a definite time interval, right? So Redis time series helps you to manage those time series data. It is mostly used for Internet of Things, stock prices, and telemetry. I would recommend you to go to redislabs.com/tech blog, and you can see amazing blogs written by the Redis Labs engineers on the stock prices, like how you can do a kind of a financial trading. How can you build the application based on the financial trading rightly using Redis time series, Redis gears, and all this thing. And the beauty of Redis time series is that you can query millions of samples, okay? Millions of samples and events, which is at the speed of Redis. And Redis completely works on your memory, right? So that's why it is fast. Irrespective of other relational databases, which uses disk, Redis uses memory. Okay, and we do have a support for Redis on Flash, which is with the enterprise version. So if you are really worried about the hot and the cold data, all of these things, you can still use Redis Enterprise. And you can also use Redis time series for an advanced tooling, like a down sampling, aggregation, all these things, the queries over the queries, all these things. And you want to really get more and more data around the different timestamps, you can get it. And one of the good news for DevOps engineers is if they are really working with Redis developers inside their organization, they can definitely go ahead and look at the integration. So we have an integration with the Datadog. We have an integration with the Grafana, Prometheus, and Telegraph, and all those monitoring tools, which basically helps you to monitor all those microservices or distributed system. So this is a kind of a snippet of command. Since Redis is is a key value database system, so we have a key called as TS carbon monoxide. This is a kind of one example of air quality monitoring system. And this is how you go ahead and create those keys. Like ts.create is a Redis time series specific command, which you can create a key value pair. And so the way how you do, you first create a new time series, you add a sample to it, and then you try to run a query on top of it. So this is one example of air quality sensor data, where you have 3 different keys: carbon monoxide, relative humidity, and the temperature. And the way how you add the samples, right? You add a new sample is like shown in the second example, where we have ts.add. So that is basically a command which you can run, and then you have ts.get, because get is the command, So it is very easy to understand. With add, you can add the samples, and with get you can basically query it. Now when I started with this kind of an architecture, so the first thing is we need to get an hardware in place, right? And that is where your Jetson Nano 2 GB model, which is like $59, and you have even I would say if it works with 4 GB also, it's just like form factor difference. You need a 5-volt 4 ampere. So if you're thinking like if you can use your mobile adapter, it is not going to work, because mobile adapter is more like a 5-volt, but this is something like 5-volt 4 ampere. So you need to have a separate adapter. With 2 GB, we have a support for Type C, so that will handle all the situations. You don't really have to worry about the power. On Jetson Nano, you have an operating system running on top of it, and that operating system is Ubuntu. Okay. And that consumes space for sure. And the whole operating system runs on your SD card, just like in your laptop or in your server, you have a hard disk or SSD drive. In Jetson, we use an SD card, and that is our hard drive. So for this demo, I used around 128 GB because I have a couple of containers which I have to run on top of it. So Grafana runs inside a container. You have a RedisTimeSeries which runs inside a container, and even the Python script which I have developed, that runs inside the container. So, and then the major part is BME 680. And coming to this is how the Jetson Nano it looks like. It has a micro SD card slot. We have an HDMI output port, and it is a full-fledged laptop kind of a stuff where you have all those ports available. And also it has a GPIO pin where you can go ahead and use it for certain kind of sensors control. Also a display unit HDMI is supported for this. To just take you through, so one of the things which I want to talk about is a BME 680. I think we have already talked about it, but this is a kind of a sensor which can help you to go ahead and monitor it. All you have to do is just insert it on the Jetson, power it on, and we are well good to go ahead and prepare the setup. Now, to prepare the setup, the first and foremost thing is you have to, if you want to run a latest version of Docker on top of Jetson Nano, you can do it. You just have to go ahead and install it. And then I have created a kind of a Docker image, which is RedisTimeSeries-Jetson. So you can pull it and you can run it. And this image is also going to work on your Raspberry Pi. So if you have a Raspberry, because this is the image which you build on a laptop is like an x86 based image, but for devices like Jetson Nano, it has to be an ARM based image. So if you try to run it on your laptop, it might or might not work. But this is an image which I created for you guys to go ahead and try it out. And also we have a Grafana. It's just a single liner command to expose it port 3000, and then you have a sensor script. So let me jump directly to one of the demo which I'm going to show you. So let me see if things are good. So this is some kind of a sensors which I have already set up. So I have just stopped it. So first and foremost thing is right now, if I have to, I hope this is visible. So I have cat etc issue. I have an Ubuntu which is running on top of it, and this is basically I am rightly on top of the Jetson Nano board. Okay, so if you see here ARC64, it basically is a Jetson Nano board right now. And the way how it is going to be is I have a kind of a repo. Let me go ahead and look into it. Hang on. So if you go to, so let me go to the github.com/Redis developers/Redis datasets. Okay. And there are a couple of sample Redis datasets here. And one of the thing which of our interest is basically a real-time IoT sensor data, where you can see all those codes are available. And one of the thing which we have developed here is a kind of a Python script which basically takes all those BME 680 modules. I'm going to show you an example on this. So this is a kind of a Python script which fetches the sensor data. We can run it on inside a container, but at the same time, there is an option where I can go ahead and I will show you an example where I run it manually so that you will get to know. So let me go through this. So what initially we have certain modules which have to import. BME 680 is a module which basically allows you to fetch the data from the sensor, and there are few of the parameters which we are setting it up, say like the humidity, pressure, and temperature. So these are the three the oversampling settings which has to be tweaked. And then we are passing all especially the information related to the Redis. So this is where we are specifying the port and the password. So I'm going to show you Redis Enterprise Cloud because that is up and running, but I can also run it directly on top of Jetson Nano 2. And these are the keys. So since Redis time series is basically based on the key value database, right? So we have all these key which we have declared here. And then all the rest of the code is basically we are trying to execute commands like ts.add, which basically adds your time series, and ts.get, which fetches that value. Okay, so what I'm going to do here is I have already cloned this repo. So let me say Redis time series. Sorry, Redis time series. And then under the Redis time series, we have real-time sensors, and this is where the code is. Okay. And one other thing which we are going to run, so I just took it for this. So I am going to run a kind of a Python script with this, and this is my host. Now let me show you how to set up a kind of, if you go to app.redislabs.com, so let me log in into it. Okay. So I'm just authenticating here. So once you log in into it, I have created a kind of a database, which is a time series based database. So if you go if you go ahead and create a new database, there is an option where you can select a module. So if you see here, there is a subscription name which we don't need, but what we need is an endpoint here, the password. I can go ahead and see the password. So this is a kind of a demo which I have created, and then you have to select a Redis time series. So this is what is the endpoint of Redis Enterprise Cloud database, which I'm going to use it. And so what we are going to do, we are going to fetch the data or the sensor data from our IoT device and push it directly to the Redis Enterprise Cloud. So let us do that, and let me go ahead. So the first and foremost thing, what I'm going to do it, I wanted to show you like where are the containers which are running here. So if I go to Docker PS and authenticate myself, I can see that there are already I have run a time series Jetson, Redis time series Jetson based Docker image or Docker container, which is already running. I have also a Grafana, which is up and running here. Okay, there is just a very simple command. So let me go through each one of these commands one by one. So this is how the whole demo is going to look like. The first thing is let's verify if the Docker is installed or not. So we have already verified that, and verify if the sensor is detected. So I'm going to pick this link and put it right here. So if it is shows me a kind of, so if you see the 76, this is what it shows. Basically it basically scans the I2C and then detects. So right now it detects that the sensor is detected, sensor is present. Okay, if you really want to go ahead and want to build a Docker image, so I have a steps. I'm going to share this link at the end of the session, so you can just clone the Redis time series, our official GitHub repo, and try to build it. So right, and what you need to do here is run a Docker run and time series hyphen Jetson, and it is going to it will show you whether the time series database is modules is up or not. So you can use info module command to basically see the modules. So it shows like this particular module is up and running. So this is what we did. We clone the repo, and there are few of the modules which you have to basically go ahead and use it. One is you need to use pip, and then install BME 680 assemblers and the Redis. So these are like you need to use the Redis client, which uses Python, and then you have a few of the modules which you have to load. And once it is done, one way is if you are running Redis locally, you can run Python 3 sensor loader 2.py, and this is and kind of a standard port which Redis runs on, so you can run on top of it. Okay, and this is let's go ahead and run it. So right now I have already used a local host like when I was deploying a few days back, but I want to use a Redis Enterprise Cloud itself because that is something which is free. So you have a choice using any of them. So let me go ahead and try to pick up this particular command which uses Python, and then at any point of time you can go ahead and do it. So once I run this command, it start fetching all those sensor data. So you see here these are the 3 different values. One is temperature, pressure, and the humidity. Now since we have already Grafana up and running, so let me open a Grafana dashboard here, which is right here. So you just have to run a kind of command. So the first and foremost thing what we need to do is we need to go ahead and if you go to the Grafana dashboard, there is a kind of, we have a Redis data source of Grafana which is supported. So I will select Redis here. Okay, once you select, you need to specify the values here. So this address is going to be our Redis Enterprise Cloud. Okay, because that is where we are going to plot it, right? And then we have a password. I will go ahead and save the test. It says data source is working unexpected. So now we have a 3 different dashboards. So if I go ahead and select Redis, it basically gives me all this information like ops, network, memory, and all this thing. So Grafana is free of cost, so you can use it at any point of time. So you see here all those different commands being executed here because these are the sensor values which are getting added. This looks fancy, but at the same time, I am more interested in plotting a kind of IoT sensors data, right? And that is where I will go ahead and add a panel here. So let me go ahead. So if you go to the data source, I will choose Redis. Now, Redis data source for Grafana supports all those the modules. So right now, if you see, we have a support for Redis Gears, Graph, Redis Search, time series. So since we are using time series, I'm going to choose this command. And then what kind of a query you want to run. So we have a ts.get, and then let me add the first key, which would be temperature. I'm going to set a kind of an interval of 500 milliseconds. So you can see here the streaming interval is millisecond, and then I say run. Now, once I click on the run, the visualization I can pick up as a gauge, and you can see here the panel here, which says like the panel list here. I am going to say IoT, or I am going to say temperature. Okay, and say apply. So I have the temperature in the form of the gauge, right? Now let's add the next panel, which would be, I'm again picking up Redis time series, Redis get, and this time I'm going to pick up pressure. Okay, once I pick up the pressure, the same thing, the 500 millisecond interval, and then under the gauge, I'm going to put it like this, and here I'm going to change it as a pressure here. So I got this, and the last one is humidity. Now for the humidity, the same stuff which I'm going to do quickly. Where you have ts.humidity, I hope I spelled it correct, and then 500. So this looks good, and I'm going to choose the time series as a gauge, and this is how you will have humidity. Okay, and apply that. Now this is how basically you plot the graph over the Grafana, and this gives you an idea about how really we can do some kind of an IoT analytics. Now this is really important at the same time because it was so easy, right? It just took around 5 minutes, less than 5 minutes to go ahead and set it up. So the idea is you have one Python script which is running on top of your Jetson Nano, and then you are pushing that data directly over to the Redis Enterprise Cloud, which is nothing but a Redis server with time series modules which is enabled. And then after that, you are plotting it over the Grafana. So with these three different steps, and all of these things can be run inside a container. We have a Grafana running inside a container. We have a Redis time series running inside a container. And just to showcase you an example, maybe we can also create a kind of a one Docker compose file and put everything on top of it. And this is something which I wanted to showcase it to you. And this is what we did here, right? And we collected the sensor data from our IoT device, put it in the Redis time series, which is again running on top of a Jetson, and then put it in the Grafana. Now, one of the thing, which I want to I want to talk about is like this is just one example. This is how you basically plot all those temperature, and this gives you an idea. And this was really helpful for our in-house project, because we really need to look into whether our food packets are going to have a favorable temperature, pressure, and humidity inside the container, so that the food has to, because when you deliver a food, one of the first thing is it should be hot, but at the same time there are certain temperature which has to be maintained, right? So we use BME 680 for most of our cases. There are other sensors which you use, lidar sensor, which is more on trying to avoid the obstacle and try to find out whether the objects comes in front of you or not. But this was something I wanted to showcase. If you are really interested to implement it, definitely you can go to the first blog which you see in the screen, how to manage real-time IoT sensor data. And there are infinite possibilities of how you implement it with a system. And this Python script is going to, if you are picking up any new sensor or any different kind of a sensor, you just have to go ahead and load that module. That's it. You can also go to developer.redislabs.com. So this is I want to spend some time here so that it becomes easy for you to really say 5 minutes to give you an idea about what we have been doing here. So developer.redislabs.com is a site for it's a kind of a developer journey where you start from create, develop, and explore. And it basically you can go ahead, you can find the resources by the languages, you can build with the Redis modules and how to tutorials and all this thing. And even if you are really interested to say start with the time series, you can just go here and say start with the time series tutorials. Like we have each and every, so these are like a step by step detailed information how to go ahead. So this is basically how I set up Redis time series modules on top of Redis Cloud for my setup. So where you have to go ahead, click on. So if you see here, we have a different modules here: Redis, Bloom, JSON, Graph, and Search. And you have to just select the time series. And if you really want to start with all these examples, we have all the sample code, how you query, how do you guess the last sample, how you get the last sample matching a specific filter. All of those queries are supported today, so you can run on top of it. And even if the Redis time series is also something which which can help you in the stock prices also, right? One of the other thing where you can really get into it is, like, if you really want to learn about Redis data source for Grafana, what are these features and capabilities. So with Grafana 8 we have a Redis Explorer which is coming in. So that is something which is promising. So if you really want to learn more about Redis data source or Grafana, how to set it up and how to install it using Docker Compose, Homebrew, and then all these things. So there are a bunch of stuff which is available in developer side, and this site is for the community. So feel free to go ahead, contribute for it. And hopefully if there is anything which you want to discuss, feel free to reach out to me. And these are like bunch of other the links which I was talking about. I have also one of the blog which I have which shows like how to run everything in the container, which is posted in Collabnix. So yeah, so this is what I wanted to show, and I am towards the end of the session. If there is any question, so let me look at if there is any specific question here. One of the question is Okay. Okay, fine. I think this is already been answered here. After IoT data is transferred to pipeline, Microsoft will the process persisted. Yeah, so I would like to take this question. Yeah, so definitely there are like Redis can be used also as a primary database, right? So think of it as like if you are running Redis inside a Docker container, at the same time, if you want to persist the data, so you can always go ahead and we have a certain settings in a Redis conf which allows you to go ahead and persist the data. So Redis can is not just a caching; it is also used as the primary database. So you can always use that. And okay, so the other question is how much does a Jetson Nano board cost? So usually it is like the 2 GB cost around $59. So it is available in India, as well as we have a 4 GB which cost around $99. Okay. Now these two boards, even when an NVIDIA launched 2 GB around like if you look at the Raspberry Pi, the only the difference what you see, what you get is like if you are like planning to buy whether the Raspberry Pi or Jetson, I would prefer, or I would I don't work for NVIDIA, but I would suggest you to go for Jetson, because with the Jetson you get a GPU device. If you really want to use it with the Raspberry Pi, there are chances that you need to have separate equipments to make it work. But Jetson comes with GPU device where you can run all the deep streaming, object detection, analytics, all sort of things. And think of it as like whatever the robotic platform which we are trying to build, it basically uses the AI. It runs a lot of AI workload. So you can there is a kind of a Jetson, NVIDIA Jetson software stack which you can build on top of it. Um, and so yeah, so I think that is helpful. So what is the cost of building the entire system? Yeah, I think I was expecting that kind of a question. So if you see like usually if you see if you look at the Amazon Scott and all these things, those are like high-end devices which they use for the package delivery. They have already started the service. And then there are few of the other vendors which have been doing, especially in China as well as in US. So usually this cost around 3 to 4 lakhs rupees. But what I am planning to do is something in across like $700 to $800. So that is going to be the cost, entirely the cost. The main cost, which if you look at the equipments itself, we have a 3D printer which cost around 70 to 80,000 rupees. The Prusa one which we have been using. And then but if you just talk about the hardware, we have a Jetson which cost around $99, and rest of the things like the lidar sensor which cost around 4 to 5,000 rupees. And then we have a if you look, most probably even the RoboMaster cost around 500. But RoboMaster is just like for the prototype which we are going to use. The entire final product is going to look a little different here. I'm expecting to build the first complete prototype by October, and then I have a presentation in the ARM Dem Summit where I'm going to, if I get a chance, I want to showcase this. But still, we have around 2 to 3 months to go trying to build, and definitely we can have one session in our meetup where we will go ahead, where I can go ahead and collaborate with the Python developer and try to see showcase that particular device. So yeah, so I don't see any further questions. So if there is any, do let us know. First of all, thank you so much for being with us. And also, I would like to thank Janis. He has been very comfortable to work with. So so if you think like you have a kind of very interesting Redis story to share, just reach out to me. And definitely there is a lot of room of collaboration which we can do. We are also planning to conduct these meetups every 2 months. But if there are more and more stuffs coming in and more speakers, definitely we can make it every month at least. So we are open for the feedback. Do let us know. And one of the thing which I want to say is if you really want to get started with the Redis journey, developer.redislabs.com is a site. It is completely hosted on Docusaurus, which is a product from the Facebook, as well as it is hosted over GitHub. So if you have used a GitHub in the past, and if you are more interested to contribute, just raise a PR, and I would be happy guy to go ahead and merge it. So thank you so much for your day. It has been really great talking about IoT shipping technology from Janis. So we look forward to collaborate, and we'll be back soon after 2 months with another interesting chapter. So thank you and have a great day. Okay.